Good afternoon, dear students of IT 6208, System Integration and Architecture 1. I am your OLC, Ms. Karen De Lara, and welcome to our virtual class today. So we will be discussing the following: SDLC models, Waterfall model, Iterative model, Spiral model, V model, Big Bang model, Agile model, and the Rapid Application Development or RAD model. SDLC models. So there are various system development lifecycle models defined and designed, which are followed during the software development process. So these models are also referred as software development process models. So each process model follows a series of steps unique to its type to ensure success in the process of software development. Following are the most important and popular SDLC models followed in the industry. So we have the waterfall model, iterative model, spiral model, V model, and the Big Bang model. Other related methodologies are agile model, rapid application development model, and the prototyping models. Let us first discuss the concept of the waterfall model. The waterfall model was the first process model to be introduced. It is also referred to as a linear sequential life cycle model. It is very simple to understand and use. In a waterfall model, each phase must be completed before the next phase can begin, and there is no overlapping in the phases. The waterfall model is the earliest SDLC approach that was used for software development. The waterfall model illustrates the software development process in a linear sequential flow. This means that any phase in the development process begins only if the previous phase is complete. In this waterfall model, the phases do not overlap. So here is a sample diagram of the waterfall model design. So it consists of the requirement analysis, system design, implementation, testing, deployment, and maintenance. The sequential phases in waterfall model are requirement gathering and analysis. All possible requirements of the system to be developed are captured in this phase and documented in a requirement specification document. System design, the requirement specifications from first phase are studied in this phase, and the system design is prepared. This system design helps in specifying hardware and system requirements and helps in defining the overall system architecture. Implementation, with inputs from the system design, the system is first developed in small programs called units, which are integrated in the next phase. Each unit is developed and tested for its functionality, which is referred to as unit testing. Integration and testing. All the units developed in the implementation phase are integrated into a system after testing of each unit. Post-integration, the entire system is tested for any faults and failures. Deployment of system. Once the functional and non-functional testing is done, the product is deployed in the customer environment or released into the market. Maintenance, there are some issues which come up in the client environment. To fix those issues, patches are released. Also, to enhance the product, some better versions are released. Maintenance is done to deliver these changes in the customer environment. Waterfall model application. Every software developed is different and requires a suitable SDLC approach to be followed based on the internal and external factors. Some situations where the use of waterfall model is most appropriate are requirements are very well documented, clear and fixed, product definition is stable, technology is understood and is not dynamic, there are no ambiguous requirements, Ample resources with required expertise are available to support the product. The project is short. Some of the major advantages of the waterfall model are as follows. Simple and easy to understand and use, easy to manage due to the rigidity of the model. Each phase has specific deliverables and a review process. Phases are processed and completed one at a time. Works well for smaller projects where requirements are very well understood, clearly defined stages, well understood milestones, easy to arrange tasks, process and results are well documented. The major disadvantages of the waterfall model are as follows. No working software is produced until late during the life cycle. High amounts of risk and uncertainty. Not a good model for complex and object-oriented projects. Poor model for long and ongoing projects. Not suitable for the projects where requirements are at a moderate to high risk of changing. So risk and uncertainty is high with this process model. It is difficult to measure progress within stages, cannot accommodate changing requirements. Adjusting scope during the life cycle can end a project. Integration is done as a big bang at the very end, which doesn't allow identifying any technological or business bottleneck or challenges early. Next, we have the iterative model. So in the iterative model, iterative process starts with a simple implementation of a small set of the software requirements and iteratively enhances the evolving versions until the complete system is implemented and ready to be deployed. An iterative life cycle model does not attempt to start with a full specification of requirements. Instead, development begins by specifying and implementing just part of the software, which is then reviewed to identify further requirements. This process is then repeated, producing a new version of the software at the end of each iteration of the model. So here is an example of a diagram of an iterative model design. So it consists of requirements, build 1, build 2, and build 3. Then the different phases are design and development, testing, and implementation. Iterative and incremental development is a combination of both iterative design or iterative method and incremental build model for development. During software development, more than one iteration of the software development cycle may be in progress at the same time. So this process may be described as an evolutionary acquisition or incremental build approach. In this incremental model, the whole requirement is divided into various builds. And during each iteration, the development module goes through the requirements, design, implementation, and testing phases. Each subsequent release of the module adds function to the previous release. The process continues till the complete system is ready as per the requirement. Iterative model application. Like other SDLC models, iterative and incremental development has some specific applications in the software industry. This model is most often used in the following scenarios. Requirements of the complete system are clearly defined and understood. Major requirements must be defined. However, some functionalities or requested enhancements may evolve with time. There is a time to the market constraint. A new technology is being used and is being learned by the development team while working on the project. Resources with needed skill sets are not available and are planned to be used on contract basis for specific iterations. There are some high-risk features and goals which may change in the future. Advantages of the iterative model. Some working functionality can be developed quickly and early in the life cycle. Results are obtained early and periodically. Parallel development can be planned, progress can be measured, less costly to change the scope and requirements. Testing and debugging during smaller iteration is easy. Risks are identified and resolved during iteration, and each iteration is an easily managed milestone. Easier to manage risks, high risk part is done first. With every increment, operational product is delivered. Issues, challenges, and risks identified from each increment can be utilized or applied to the next increment. Risk analysis is better. It supports changing requirements. Initial operating time is less, better suited for large and mission critical projects. During the life cycle, software is produced early, which facilitates customer evaluation and feedback. Next, let's discuss the disadvantages of iterative model. More resources may be required, although cost of change is lesser, but it is not very suitable for changing requirements. More management attention is required. System architecture or design issues may arise because not all requirements are gathered in the beginning of the entire life cycle. Defining increments may require definition of the complete system, not suitable for smaller projects. Management complexity is more. End of project may not be known, which is a risk. Highly skilled resources are required for risk analysis. Project's progress is highly dependent upon the risk analysis phase. Next, we have the spiral model. The spiral model combines the idea of iterative development with the systematic controlled aspects of the waterfall model. This spiral model is a combination of iterative development process model and sequential linear development model. Example, the waterfall model with a very high emphasis on risk analysis. It allows incremental releases of the product or incremental refinement through each iteration around the spiral. So the spiral model has four phases. So a software project repeatedly passes through these phases in iterations called spirals. Identification. This phase starts with gathering the business requirements in the baseline spiral. In the subsequent spirals, as the product matures, identification of system requirements, subsystem requirements, and unit requirements are all done in this phase. This phase also includes understanding the system requirements by continuous communication between the customer and the system analyst. At the end of the spiral, the product is deployed in the identified market. Design. The design phase starts with the conceptual design in the baseline spiral and involves architectural design, logical design of modules, physical product design, and the final design in the subsequent spirals. Construct or build. So the construct phase refers to production of the actual software product at every spiral. In the baseline spiral, when the product is just thought of and the design is being developed, a proof of concept is developed in this phase to get customer feedback. Then, in the subsequent spirals with higher clarity on requirements and design details, a working model of the software called build is produced with a version number, and these builds are sent to the customer for feedback. Evaluation and risk analysis. Risk analysis includes identifying, estimating, and monitoring the technical feasibility and management risks, such as schedule slippage and cost overrun. After testing the build, at the end of first iteration, the customer evaluates the software and provides feedback. So here is an illustration of the spiral model. So again, it consists of various phases such as identification, design, construct or build, and evaluation and risk analysis. Spiral model application. The spiral model is widely used in the software industry as it is in sync with the natural development process of any product, like learning with maturity, which involves minimum risk for the customer as well as the development firms. So the following pointers explain the typical uses of a spiral model. When there is a budget constraint and risk evaluation is important, for medium to high risk projects, long-term project commitment because of potential changes to economic priorities as the requirements change with time. Customer is not sure of the requirements, which is usually the case. Requirements are complex and need evaluation to get clarity. New product line which should be released in phases to get enough customer feedback. Significant changes are expected in the product during the development cycle. Advantages of spiral model. Changing requirements can be accommodated, allows extensive use of prototypes. Requirements can be captured more accurately. Users see the system early. Development can be divided into smaller parts, and the risky parts can be developed earlier, which helps in better risk management. The disadvantages are as follows. Management is more complex. End of the project may not be known early. Not suitable for small or low risk projects and could be expensive for small projects. Process is complex. Spiral may go on indefinitely. Large number of intermediate stages requires excessive documentation. Next, we have the V model. The V model is an SDLC model where execution of processes happens in a sequential manner in a V shape. It is also known as verification and validation model. The V model is an extension of the waterfall model and is based on the association of a testing phase for each corresponding development stage. This means that for every single phase in the development cycle, there is a directly associated testing phase. So this is a highly disciplined model, and the next phase starts only after completion of the previous phase. So here is an example illustration of the V model design. V model verification phases. So there are several verification phases in the V model. Each of these are explained in detail below. Business requirement analysis. So this is the first phase in the development cycle where the product requirements are understood from the customer's perspective. This phase involves detailed communication with the customer to understand his expectations and exact requirement. This is a very important activity and needs to be managed well, as most of the customers are not sure about what exactly they need. The acceptance test design planning is done at this stage as business requirements can be used as an input for acceptance testing. System design. Once you have the clear and detailed product requirements, it is time to design the complete system. The system design will have the understanding and detailing the complete hardware and communication setup for the product under development. The system test plan is developed based on the system design. Doing this at an earlier stage leaves more time for the actual test execution later. Architectural design. Architectural specifications are understood and designed in this phase. Usually, more than one technical approach is proposed, and based on the technical and financial feasibility, the final decision is taken. The system design is broken down further into modules, taking up different functionality. So this is also referred to as high-level design. So the data transfer and communication between the internal modules and with the outside world or other systems is clearly understood and defined in this stage. With this information, integration tests can be designed and documented during this stage. Next, we have the module design. So in this phase, the detailed internal design for all the system modules is specified. So this is referred to as the low level design. It is important that the design is compatible with the other modules in the system architecture and the other external systems. The unit tests are an essential part of any development process and helps eliminate the maximum faults and errors at a very early stage. These unit tests can be designed at this stage based on the internal module designs. Next, we have the coding phase. The actual coding of the system modules designed in the design phase is taken up in the coding phase. The best suitable programming language is decided based on the system and architectural requirements. The coding is performed based on the coding guidelines and standards. The code goes through numerous code reviews and is optimized for best performance before the final build is checked into the repository. So the different validation phases in a V model are explained in detail below. Unit testing. Unit tests designed in the module design phase are executed on the code during this validation phase. Unit testing is the testing at code level and helps eliminate bugs at an early stage, though all defects cannot be uncovered by unit testing. Integration testing is associated with the architectural design phase. Integration tests are performed to test the coexistence and communication of the internal modules within the system. System testing is directly associated with the system design phase. System tests check the entire system functionality and the communication of the system under development with external systems. Most of the software and hardware compatibility issues can be uncovered during this system test execution. Acceptance testing is associated with the business requirement analysis phase and involves testing the product in user environment. Acceptance tests uncover the compatibility issues with the other systems available in the user environment. It also discovers the non-functional issues such as load and performance defects in the actual user environment. V-model application. V-model application is almost the same as the waterfall model, as both the models are of sequential type. Requirements have to be very clear before the project starts because it is usually expensive to go back and make changes. So this model is used in the medical development field as it is strictly a disciplined domain. So the following pointers are some of the most suitable scenarios to use the V model application. Requirements are well defined, clearly documented and fixed. Product definition is stable. Technology is not dynamic and is well understood by the project team. There are no ambiguous or undefined requirements, and the project is short. The advantages of the V model method is that it is very easy to understand and apply. The simplicity of this model also makes it easier to manage. So the advantages of the V model method are as follows. This is a highly disciplined model and phases are completed one at a time. Works well for smaller projects where requirements are very well understood. Simple and easy to understand and use. Easy to manage due to the rigidity of the model. Each phase has specific deliverables and a review process. The disadvantages is that the model is not flexible to changes, and just in case there is a requirement change, which is very common in today's dynamic world, it becomes very expensive to make the change. So the disadvantages of V model are high risk and uncertainty, not a good model for complex and object-oriented projects, poor model for long and ongoing projects, not suitable for the projects where requirements are at a moderate to high risk of changing. Once an application is in the testing stage, it is difficult to go back and change a functionality. No working software is produced until late during the life cycle. Next model is the Big Bang. The Big Bang model is an SDLC model where we do not follow any specific process. The development just starts with the required money and efforts as the input, and the output is the software developed, which may or may not be as per customer requirement. This Big Bang model does not follow a process or procedure, and there is a very little planning required. Even the customer is not sure about what exactly he wants, and the requirements are implemented on the fly without much analysis. Usually, this model is followed for small projects where the development teams are very small. Big Bang Model Design and Application. The Big Bang model comprises of focusing all the possible resources in the software development and coding, with very little or no planning. The requirements are understood and implemented as they come. Any changes required may or may not need to revamp the complete software. So this model is ideal for small projects with one or two developers working together, and it is also useful for academic or practice projects. It is an ideal model for the product where requirements are not well understood and the final release date is not given. Advantages of the Big Bang model are this is a very simple model, little or no planning required, easy to manage, very few resources required, gives flexibility to developers. It is a good learning aid for newcomers or students. Disadvantages of the Big Bang model are very high risk and uncertainty, not a good model for complex and object-oriented projects, poor model for long and ongoing projects, can turn out to be very expensive if requirements are misunderstood. Next, we have the Agile model. Agile SDLC model is a combination of iterative and incremental process models with focus on process adaptability and customer satisfaction by rapid delivery of working software product. Agile methods break the product into small incremental builds. So these builds are provided in iterations. Each iteration typically lasts from about 1 to 3 weeks. Every iteration involves cross-functional teams working simultaneously on various areas like planning, requirement analysis, design, coding, unit testing, and acceptance testing. At the end of the iteration, a working product is displayed to the customer and important stakeholders. So what is Agile? Agile model believes that every project needs to be handled differently and the existing methods need to be tailored to best suit the project requirements. In Agile, the tasks are divided to time boxes or small time frames to deliver specific features for a release. Iterative approach is taken and working software build is delivered after each iteration. Each build is incremental in terms of features, and the final build holds all the features required by the customer. So this is the graphical illustration of Agile model. So for iteration 1, 2, and 3, we have planning, requirement analysis, designing, building, and testing. So Agile Manifesto Principles. Individuals and interactions. In agile development, self-organization and motivation are important, as are interactions like co-location and pair programming. Working software. Demo working software is considered the best means of communication with the customers to understand their requirements instead of just depending on documentation. Customer collaboration, as the requirements cannot be gathered completely in the beginning of the project due to various factors, continuous customer interaction is very important to get proper product requirements. Responding to change, agile development is focused on quick responses to change and continuous development. Agile versus the traditional SDLC models. Agile is based on the adaptive software development methods, whereas the traditional SDLC models, like the Waterfall model, is based on a predictive approach. Predictive teams in the traditional SDLC models usually work with detailed planning and have a complete forecast of the exact tasks and features to be delivered in the next few months or during the product life cycle. Predictive methods entirely depend on the requirement analysis and planning done in the beginning of cycle. Any changes to be incorporated go through a strict change control management and prioritization. Advantages of the Agile model. A very realistic approach to software development, promotes teamwork and cross-training. Functionality can be developed rapidly and demonstrated. Resource requirements are minimum, suitable for fixed or changing requirements, delivers early partial working solutions, good model for environments that change steadily, minimal rules, documentation easily employed, enables concurrent development and delivery within an overall planned context, little or no planning required, easy to manage, and gives flexibility to developers. The disadvantages of agile model are not suitable for handling complex dependencies, more risk of sustainability, maintainability, and extensibility, an overall plan, an agile leader, and agile PM practice is a must, without which it will not work. Strict delivery management dictates the scope, functionality to be delivered, and adjustments to meet the deadlines. Depends heavily on customer interaction. So if customer is not clear, team can be driven in the wrong direction. There is a very high individual dependency since there is minimum documentation generated. Transfer of technology to new team members may be quite challenging due to lack of documentation. Next, we have the RAD model. So the RAD, or also known as the Rapid Application Development Model, is based on prototyping and iterative development with no specific planning involved. The process of writing the software itself involves the planning required for developing the product. Rapid application development focuses on gathering customer requirements through workshops or focus groups. Early testing of the prototypes by the customer using iterative concept, reuse of the existing prototypes or components, continuous integration, and rapid delivery. So what is RAD? Rapid application development is a software development methodology that uses minimal planning in favor of rapid prototyping. A prototype is a working model that is functionally equivalent to a component of the product. In the RAD model, the functional modules are developed in parallel as prototypes and are integrated to make the complete product for faster product delivery. Since there is no detailed pre-planning, it makes it easier to incorporate the changes within the development process. RAD projects follow iterative and incremental model and have small teams comprising of developers, domain experts, customer representatives, and other IT resources working progressively on their component or prototype. RAD model design. So we have the business modeling. The business model for the product under development is designed in terms of flow of information and the distribution of information between various business channels. A complete business analysis is performed to find the vital information for business, how it can be obtained, how and when is the information processed, and what are the factors driving successful flow of information. Data modeling. The information gathered in the business modeling phase is reviewed and analyzed to form sets of data objects vital for the business. The attributes of all data sets is identified and defined. The relation between these data objects are established and defined in detail in relevance to the business model. Process modeling. The data object sets defined in the data modeling phase are converted to establish the business information flow needed to achieve specific business objectives as per the business model. The process model for any changes or enhancements to the data object sets is defined in this phase. Process descriptions for adding, deleting, retrieving, or modifying a data object are given. Next, we have the application generation. The actual system is built and coding is done by using automation tools to convert process and data models into actual prototypes. Testing and turnover. The overall testing time is reduced in the RAD model as the prototypes are independently tested during every iteration. However, the data flow and the interfaces between all the components need to be thoroughly tested with complete test coverage. Since most of the programming components have already been tested, it reduces the risk of any major issues. So here is an example of an illustration of the RAD model. So for prototype 1, 2, and 3, so we have the different phases such as business modeling, data modeling, process modeling, application generation, testing, and turnover. RAD model versus the traditional SDLC. The traditional SDLC follows a rigid process models with high emphasis on requirement analysis and gathering before the coding starts. It puts pressure on the customer to sign off the requirements before the project starts, and the customer doesn't get the feel of the product as there is no working build available for a long time. The customer may need some changes after he gets to see the software. However, the change process is quite rigid and it may not be feasible to incorporate major changes in the product in the traditional SDLC. The RAD model focuses on iterative and incremental delivery of working models to the customer. So this results in rapid delivery to the customer and customer involvement during the complete development cycle of product, reducing the risk of non-conformance with the actual user requirements. RAD model application. RAD should be used only when a system can be modularized to be delivered in an incremental manner. It should be used if there is a high availability of designers for modeling. It should be used only if the budget permits use of automated code generating tools. RAD SDLC model should be chosen only if domain experts are available with relevant business knowledge. Should be used where the requirements change during the project and working prototypes are to be presented to customer in small iterations of 2 to 3 months. Advantages of RAD model: changing requirements can be accommodated, progress can be measured, iteration time can be short with use of powerful RAD tools, productivity with fewer people in a short time, reduced development time, increases reusability of components, quick initial reviews occur, encourages customer feedback, integration from very beginning solves a lot of integration issues. The disadvantages of RAD model are dependency on technically strong team members for identifying business requirements. Only system that can be modularized can be built using RAD. Requires highly skilled developers or designers. High dependency on modeling skills. Inapplicable to cheaper projects as cost of modeling and automated code generation is very high. Management complexity is more. Suitable for systems that are component based and scalable. Requires user involvement throughout the life cycle. Suitable for project requiring shorter development times. So if you have any questions, please send a message through the LMS chat box, or you can also email me at kvdelara@amais.edu.ph. Thank you for listening and thank you for attending our virtual class today.